Interesting little power supply that should be quite useful to the workshop. I picked up today. It's 200 volt, 200 milliamp power supply. Should be quite useful for sort of high voltage testing on the valve radios and things like that. It's pretty basic. It's got a sort of single turn pot, and you can adjust the voltage by switching this on and just turning the voltage up to what you want. There's no current limit control, unfortunately. Now that's not the end of the world, and as you see with the switch up in the up position, it will measure voltage, and the down it will measure current. It shows here an output on. It's got an overload indicator. You've got your terminals here with adapters for adapting to a normal banana plug, and then we've got some recessed connectors in here for the high voltage protection. There's quite a few of these on eBay, and I'm not sure what they're used for. I think they're probably sort of like a medical centre might use them, or a laboratory or something. But this is a 240 volt version. They do a 110 volt version as well, as you can see there. And basically the sticker's fallen off, but that obviously covered the 110 version. And this, as I say, is a 240 volt one. So I thought, well, it would be great for testing sort of high tension stuff on the radios and things. The only limiting factor with this, of course, apart from the current limiting, is it will only work to 200, just over 200 volts. And I would like to see if I can at least be able to get it to 250 volts. But we'll have to take a look inside and see if that's possible, and try and, if I can, download a manual for it. We'll do a couple of tests first just to see if it's working as well as it says. I don't know if these are recessed in here. I can get access with the probes. Yeah, it's quite useful. I think they just plug into there. So plug these in here, so I can use these probes here. Let's turn it up to indicated 100 volts on the front panel. Okay, it's 100 volts on the front panel. Pretty good. So that's 174, 173.3. So the front panel's good, and it looks like it's accurate. So it looks good. Turn it down to minimum. Settles down to a few hundred millivolts. And this is returned to zero. Actually, the meter, I don't know if you can see this, the meter was actually, I did actually check the meter when I left work, and it was absolutely fine. But let me just zoom in a bit so you can see a little bit clearer what I'm doing. Okay, so what I'm going to do is I'll take it apart and we'll have a look inside, and just to see what's going on inside. So, actually, before I'll do that, I will check its current limit capability. So what I'm going to do is I'm going to put it into a short circuit mode and switch to current. This will test the maximum current capability of the power supply, and it should also show on here the present current going through. It's ramping. Okay, that's half an amp, 0.53, so that's clearly working fairly well as well. So let's move that back to volts so we don't put a short on the next thing I test. Let's take it apart and have a look. So unplug it. Looks like it's just 2 screws in the bottom. A bit easier for you to see. Oh god, screws are pretty tight. Okay, 2 manky old rusty M3 screws by the looks of it. And there you go, that's the insides. Looks fairly straightforward. It's obviously where you see it looks like it's a switching transistor here. This is probably the high voltage power supply. I don't know what these 4 chokes are, but they're obviously filters. Now it says FIH, so I imagine they're sort of high frequency filters. There's an octo coupler here, obviously to control the analog input to the digital encoder. We've got a single turn pots just here on the back, and the front panel. A couple of pots adjustments here that look like they're all controls for the LED readout. So it looks like it's possibly we are possibly able to adjust or try and have a go at increasing the voltage by, it looks like where this is the pots, we're looking at the pinouts down to the boards, and they go down to this header here and then down to these resistors. There is a good chance that we might be able to get a few more volts out of it. As I say, 250 volts would be pretty good. If I can get 250 volts out of it, it'll make it certainly worthwhile for high tension stuff. I don't know what make of caps they are. Is that morons? A couple of morons in here. Oh, okay. But they look okay. There's no sign of any bulging. Actually, that one's gone a bit concave. It's almost like it sucked itself empty, sort of thing. Got a fuse here with a resistor in series, so I don't know if that's some form of current limiting or just surge protection, maybe. Nicely made. And the board sort of mounted on a couple of looks like M3 screws. It's got lots of quite heavy filtering. It's got a filter on the input here. Bridge rectifier is nice and chunky. It's got looks like it's got a thermistor, or yeah, a thermistor down here, just surge arresting. So it's all quite well built and nicely laid out. Can't see any signs of any weeping capacitors or anything like that. So I think the next thing to do is have a poke about and see if we can work out if we can get any more voltage out of it. The first thing I was going to do is just track down the variable resistor. So when it's in its maximum fully clockwise position, it's on this sweeper here, so this point here and here should be at 0 ohms, which they are. So what I want to do is try and track down, and I think it goes to here. No, it doesn't. It goes to another one. It's multi-layer board, so it could be this one. No. So we can track this down. We could also have a look at centre wiper. There we go, it goes to that track there. From that track there, hopefully goes to another resistor. Nope. So what I'll probably have to do is probably have to take the board out and have a look. Let's just see if it gets anything diodes or anything here. Okay, it's gone to this diode here, and so that's not going to be quite as straightforward as I was hoping. And it goes off to a transistor, and there's interestingly enough a track's being cut there. So I don't know what that did. And then from there it went off to a resistor. So I wonder if this is like a control for the output. It's cut or not, it's showing us continuity to there. So to measure these resistors, 5k here. So it looks like it might be possible to alter some of these resistors. So it comes to what I really need is a circuit diagram. We can have a look to see what's going on here. So it comes to these resistors here, or certainly that resistor there. It looks like a track's been cut, but it clearly can't do because it's got continuity. It goes to this capacitor. I don't know where this point goes. So what I might do is I might power it up and then stick a maybe another resistor across there and just see what it does to the output voltage. So presently, as it's a 10k I'm measuring, so if I put another 10k in parallel with it, just see if it gives us any more output voltage. So plug it back in. Set that to volts. What I'll do, you can see the voltmeter there. Well, first of all, what I'll do is measure the voltage across that point. So at 207 volts full scale. So we need to go to, where are we? Where were we? This resistor here. I'm not measuring anything across there. It doesn't seem to be. Maybe bring it up slightly. So let's turn that down a bit and measure the voltage again. No, there's no voltage measuring across there, so I don't think that's going to make a huge difference. So I think after this initial check, I'm going to try and find a service manual, or at least a schematic for it. You can find that, and then we can maybe work out if we can adjust the voltage, and maybe even fit a current limit adjustment in there. The current limit should be fairly easy to spot. It's usually quite a chunky power resistor. There's actually quite a chunky power resistor down here, you see. See, this would be the current detection circuit, so we can have a look at that, and also possibly fit a current limit circuit, so that will be useful. Anyway, thanks for watching, and